Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along. Come inside, the show's about to start. Guaranteed to blow your head apart. Rest assured, you'll get your money's worth.
Hello and welcome to yet another episode in our continuing series of MetalForming Live, where our editorial team recruits expert panelists to discuss the important issues that metal formers and fabricators are dealing with today. I'm Brad Kuvan. I'm the editorial director of MetalForming magazine. I'm here live with you from the headquarters of the Precision Metal Forming Association. And I, along with senior editors Lou Kren and Kate Bachman, welcome you to today's session, where we're going to take a deep dive into end-of-line press line automation. Before we get started, I want to first and foremost thank our generous sponsors for their support, which allows us to bring you such valuable content in this easy-to-digest format. Our sponsors today are Say Presses, Stamtec, Nidec Press and Automation, and Principal Financial. So again, thanks to all of these companies for your generous support. In addition, I want to stress that these online live discussions are meant to generate ideas that you, our guests online, can bring back to your companies to help you improve operational performance, productivity, and quality. Our panelists are here to answer your questions and to discuss your ideas. So please take this opportunity, ask questions, participate in the discussions. You'll use the Q&A panel on your Zoom screen to ask questions of our panelists, and then I'll go ahead and relay your questions to the panelists. All right, so without further ado, let's meet our panel. I'll start with our editorial team, Lou and Kate, and then we'll introduce our other panelists. So, Lou?
Hi, thanks, Brad. I'm Lou Kren, senior editor with MetalForming magazine.
Hi, I'm Kate Bachman, also senior editor with MetalForming magazine.
And then Jim, how about yourself? Jim, don't forget to unmute.
Yep, I'm Jim Myers. I'm with TCR Integrated Stamping Systems. I'm the senior stamping engineer here.
And last but not least, Dean Phillips.
Hey, I am Dean Phillips. I am the technical director for Precision Metal Forming Association.
Awesome. And the host of PMA's podcast, Destiny of Manufacturing, right?
I didn't want to toot my own horn, but toot.
There you go. All right, so thanks everybody for being on the panel. We're looking forward to a great conversation. Before we get started with the actual event, I want to welcome Lee Eller. Lee is the National Sales Manager with one of our sponsor companies, Stamtec. Lee's going to offer a brief welcome message for everybody online today. So Lee, go ahead.
Hey guys, hi Brad and all of our esteemed panel members there. You got some great knowledge there. I'm looking forward to this event today. Now, Stamtec's very proud to have been involved with PMA for pretty much our entire existence. We're actually a charter member of the PMA Education Foundation, which provides scholarships to promising young students, going into metal forming and engineering in colleges nationwide. And we believe that the educational function of PMA is perhaps the most important part of the organization. So we're really happy to, we consider seminars like this one to be part of that education system. So we're very happy to be here today sponsoring this event. At Stamtec, we also value helping and educating customers. So I'd like to invite you to visit our website and our facility here at Stamtec in Manchester, Tennessee. Speaking of that, I want to share just for a moment our website and a short video about our facilities. Let's see. Okay, so our website is pretty simple. It's stamtec.com. And of course, we're going to have our product information and such as that. But we've also got a lot of information about our support services.
Yeah, and I'm sorry, Lee, we're not seeing your website right now. I'm sorry.
Let's show.
Now you got
There
it. Bingo.
Okay. So, yeah, it's a pretty simple website, stamptech.com. Of course, we've got product information about our presses and auxiliary equipment and such, but also a lot of information about our support services, which is a big part of our success at Stamptech and our ability to serve customers. Educational information where you might find some more white papers and webinars similar to what we're seeing today. And then a video section, which, especially if you're a Stamptech customer, you might find pretty useful in our service and support videos, which kind of highlight some basic service and maintenance of our equipment. Now, Stamptech is located in Manchester, Tennessee. We're about an hour from Nashville, southeast, about an hour northwest of Chattanooga, God's country, we call it, right in the middle of Tennessee. And we also have a facility in Querétaro, Mexico. So this is our facility here in Manchester. It's about a 60,000 square foot facility. And we keep it pretty well stocked with about 60 different press models, anywhere from 35 tons up to 600 tons. So we have these for quick delivery. We've got a place in Querétaro, Mexico, which is near Mexico City, about an hour west of there, northwest. And then all our presses are manufactured in our facilities in Taiwan. We've been manufacturing there for 70 plus years. We do anything from a small gap frame press up to a large transfer press, such as you see right here. And of course, full service and support right out of Stamptech in Manchester, Tennessee, and other service locations around the country. So that's the quick blurb on us. And I want to turn it back over to Brad and the other panelists at this point. Thanks a lot, guys. We appreciate being here.
Thank you very much, Lee. Now, end of press line automation, today's metal forming live topic, lacks the star power of other line automation, such as press tending, coil handling, and blank feeding. But tell that to metal formers watching their press lines idling as a bottleneck develops in removing newly formed parts and scrap. That's a rough scenario and a money-losing proposition, as this image of an underperforming press line shows. Sometimes bottlenecks form after adding new automation in other parts of the press line or when installing a state-of-the-art, swift-moving press setup. Soon enough, not addressing the tail end of the press line results in big headaches. A manual solution often can be a poor solution, resulting in tedious and/or awkward and slow handling of oddly shaped, heavy, or sharp parts. Good luck keeping such operations staffed, as few people are willing to take on such work all day, every day. And manual part handling introduces risk of injury, either resulting from repetitive motion or from trying to grip and move parts that are heavy, oddly shaped, or have sharp edges. With well-planned automation, workers on the floor can be freed for more rewarding and valued tasks. And even staffing for such manual work and retaining those performing such work can prove difficult. In its May 2024 issue, Metal Forming chronicled the efforts of R&S Roof Products, a California fabricator that added stamping to its resume through the successful installation of a new stamping press with automated coil handling. The press produces roof walkway planks, which can be 10 feet or longer from 21-inch wide material, typically 18 gauge galvanized steel. The press line performs admirably, cranking out a plank every 58 seconds. It's what happens after that has company management thinking, as automation to gain press line efficiency has caught the attention of the team. This includes downstream automation to free personnel for manual unloading of planks, which will enable even quicker plank production. One possibility, as planks exit the press line, a robotic work cell performs the bending and stacking of finished pieces, freeing employees for other tasks. R&S Roof Products currently is exploring end-of-line automation, a likely scenario with many of our attendees today. We commonly see successful end-of-line automation in fabricating operations as well, as witnessed at Gen Air, an Illinois manufacturer of industrial fans and blowers that MetalForming recently profiled. To keep pace with the newly added and fast-producing laser cutting machine, JanAir installed end-of-line parts sorting and stacking automation. Resulting productivity increases allowed the manufacturer to reduce direct labor input at the cutting machine and instead created skilled labor opportunities at downstream operations. In fact, the end-of-line automation allowed JanAir to run unattended lights out overnight. Come morning, there will be as many as 1,000 sorted and stacked parts ready for operators to move over to secondary operations such as press brake bending, welding, painting, or assembly. Without the end-of-line automation, the company's president told MetalForming, we'd be struggling to keep up with parts sorting and stacking. So rather than hire and train workers for relatively low skill sorting and stacking tasks, we're now hiring and training workers for higher skill downstream work such as welding, assembly, and painting. The automation has allowed us to increase volume and sales and push everything through the fabrication department quickly and efficiently. With so much attention paid to front of line and mid-line automation, we may consider end-of-line automation as the final frontier for metal formers to improve press line and downstream productivity. That's how frequent MetalForming Live contributor Paul Steerett, Vice President of Sales at Linear Transfer Automations, sees it. Auto racking, or automatic placement of parts off of the press and onto racks or into bins or shipping containers, represents what I see as the biggest trend and coming area of growth, Steerett tells MetalForming. Such simulation can iron out problems and optimize operations before anything is built. Steerett predicts that in coming years, we'll see the entire press room automated to a significant degree, with the greatest technology gains coming at the end of the line, thus removing a huge bottleneck. Many manufacturers, he says, still manually rack parts due to challenges when dealing with old, bent, and beat-up racks. But today, with vision systems and high-speed robotics, suppliers increasingly are quoting for this type of automation. While a transfer line may be capable of 16 strokes per minute, management limits speed to perhaps 7 strokes a minute due to the stress on manual labor at the end. Available to metal formers today, automation that removes the human element from even the most sophisticated end-of-line part handling applications, freeing associates for other safer tasks. Steerett provides a real-life example. Large automotive body panels come off of a press without even touching a conveyor, he explains. Parts drop onto a shuttle nest for transport via overhead, high-speed, linear robotic units that stage the parts for placement by pick-and-place robots into racks located on rotary tables. Fork truck removes a fully loaded rack, and the table rotates to provide a continuous supply of empty racks for the robots to fill. Automotive OEMs and Tier 1s are most interested in these full-blown auto racking solutions, as well as appliance makers. Simpler yet efficient setups may include robots that bin pick parts for placement into shipping containers, again, fully automatically. And end-of-line automation is not only for the big players like automotive OEMs and Tier 1s. The time to take on such technology, as Christian Holgard, General Manager for the Americas at OnRobot, tells MetalForming, is now. Even if a metal former can't make a case for it now, he says, cobot and robot end-of-line automation will pay off at some point when employees no longer want to take on dull, repetitive, and potentially dangerous part handling tasks. The metal former then will have to slow production to address that instead of being proactive and adding that automation now. Thankfully, there's a trend towards small and medium-sized companies employing such automation, but a huge amount still haven't automated. Now is the time for metal formers to invest in end-of-line automation. Indeed, exciting times are here today, with more coming in the area of end-of-line automation. We're going to explore this topic in detail, but first a word from MetalForming Live sponsor, SAE.
What Say can offer you from a sales perspective is a couple of things. One of them is get to know you. Who are you? What are your business needs? What are the upcoming challenges that you may face? And how SAE can provide you with a full turnkey project.
It's a very large company, but with a small company feel to it. We have a lot of flexibility and capabilities for both our domestic side here at SAE America, as well as the support from our corporate overseas. We can really offer our customers a great value for our products to help them optimize their production, their ROI on the equipment they purchase.
What I feel that makes SAE unique is the fact that we basically try to help the customer, we help think for them and try to benefit what their needs are or anticipate what they need so that we can better serve them.
SAE has a very good product. We have a full complement of presses from 28 ton all the way up to 2,500 ton presses, and we have a full complement of parts in-house in Tennessee, and also have service technicians readily available to service all of our equipment.
And typically, whenever we receive a call for parts, we can get them out same day. We have probably 95% of the parts here in Tennessee and Mexico.
SAE has a very strong service department, very strong service team. We're able to resolve the issue for the customer so that they can continue making parts and continue on with their production.
From the point of finding a press project all the way after installation of the press project, we have excellent people at the factory, we have excellent people in the US, we have excellent people in Mexico that will help you become a satisfied customer.
To discuss end of press line automation scenarios and technologies and their impact and optimization, we again welcome Jim Myers, Senior Stamping Engineer with TCR Integrated Stamping Systems, and Dean Phillips, PMA's Director of Technical Training. Now, Jim, TCR has a lot of experience in automating back halves of press lines to gain efficiencies. Starting off, can you describe some scenarios in metal stamping that cry out for end-of-line automation? And what questions should stampers be asking in assessing the need for such automation?
Sure. Thank you, Lou. As you suggested, TCR has a lot of experience with this back-end automation. That's a key part of our business, is improving efficiencies and improving those back-end and simple automations to improve your uptime and efficiency. And some of that is through our own invention, some is through our industry partners that we work with. Some of the scenarios that you want to be looking at is areas that, as plant manager, engineer, whatever, you want to reduce operator intervention, whether that is taking scrap from the press, removing parts, getting parts out. However, if you're reaching in, we all want to try and keep hands out of the press as much as possible. The other thing is keeping the presses running. We want to hear that the more often we hear pounding, that's more dollars falling in our pockets, right? So we want to see the presses running. We want to see that continually happening. Additionally, we want to reduce setup, and most important of all is safety. Again, we talked about, reaching into the press to try and get parts out, to try and get scrap out. Anytime you can eliminate putting your hands in the press, you're going to create a safer position for the operators to be in. There's also consideration of the larger presses with heavier parts. We want to make sure that operators aren't bending and reaching and stretching and causing repetitive injuries. Some of the things that they should be asking, what are you trying to accomplish? Are you trying to go faster? Are you trying to be safer? Safety, quality, productivity, right? I want to be safer. I want to make better parts, and I want to try and make them faster. So let's make it safer for the operator. Keep hands out of the die. Keep them from getting cuts and scrapes and bending and lifting and repetitive stress. Is that something? Is it quality? When you're reaching into the press to take the parts out, or are parts falling out uncontrolled manner that they're getting damaged on the way out of the press? We want to improve part quality that way. Control the exit of the part. And productivity. Can I keep that press running? Can I keep things moving? Can I reduce setup? These are all questions that you should be looking at when you're considering your end-of-line automation. A couple other things you need to really consider is how are you going to handle the parts? Is the die ready for automation? Does the part fall freely? Does the scrap fall freely? Is that one of the reasons why you have an operator reaching into the tool? You know, there may be some considerations as far as getting that tool ready for this happen. And once you get going at these higher rates, how are you going to evacuate the scrap? Is it going to be falling off in a faster manner that you're not prepared for? And should you be automating your scrap handling? And so some of the ways that, you know, the things you should be looking at as well is looking at your efficiencies, looking at your direct labor costs, looking at your productivities, and considering any injuries. So that's kind of the things that you should be considering when you're looking at automation. So I'm going to give you some examples that TCR has worked on directly, and some of our industry partners as well have provided for us. And I'm going to start with some real basic stuff. I'm going to start with scrap. So let me share my first photo here with you. This is probably the most basic, one of the most basic things you can add to a press. This is an example of a gap frame press, and the simplest part of the automation we added here was just going with a scrap handling off the back of the press. This is a electric shaker. We have trays that go all the way into the die, is what you see here. And these trays carry scrap out and drop it in a hopper behind. This eliminates the necessity for, you know, and a lot of us, and I've done this, you put a tray in underneath the die, you are pulling these trays out, you're stopping the press, operators are reaching into the guarded area. This eliminates that. Simple, very easy. The next example here, kind of a little more advanced. This is, we consider this, we call it a mother-daughter system. The mother tray is this large tray that's here in the bottom, and this is unfortunately not a brand new system, but it's working. In this case, we have smaller trays that are actually carrying the scrap, and the advantage there is storing the smaller trays. There's nothing big for the operator to be handling. It's quicker for setup. And basically you just hook these smaller trays onto a bar up in front, and they shake scrap onto a large tray. The large tray takes it out. This particular customer also utilized it to do their part out as well. So not only are we shaking the scrap out on the tray, but they put a long tray in here that carries the scrap out over the bin, or carries the final part out over the bin and drops it into another container. So we can make use of that mother-daughter system more than one way. Looking ahead, so those were two small examples of a gap frame press system. This is a straight side. Same principle. We have a shaker that's attached. There's an electric motor over on the side here. This bar rocks back and forth, takes it out. It keeps the trays shaking, and scrap is falling out into these bins. The only disadvantage here potentially is you could have an interruption in production when you come in to pull those bins out. You would hope that that doesn't happen, but there are ways in creating a more advanced system that you could carry the part out. And if you get a little planning up front, if you're doing a new system, maybe you can take advantage of the fact that you're installing a foundation to put a foundation in for a shaker. So this is talking about automation as well. This particular system, and if we zoom in right here, you see a little sensor here. What we try to do when we create a system is to start it and stop it with the press. So when the press starts, the automation starts, the tray starts shaking, everything starts moving. And this sensor right here is monitoring the motion of the bar to tell us. So you tie that into your die protection. The die protection knows I am removing scrap from the press while I'm operating. And things are working as they should. If for some reason it doesn't start, wire gets cut, some other reason the system stops, you'll get a notification and potentially a die protection stop to stop that, all in the name of automated scrap removal from your process. Next step here, as I talked about, now this was another example that we worked on, and this was another gap frame press, but we had an opportunity that this customer wanted to put a trench in the floor underneath their gap frame press. So they're actually kind of like the big OEMs. They're actually dropping scrap through the bolster and down to the floor, and then we're carrying it out through a conveyor and bringing it up the back. This bring it up into a scrap hopper outside the guarded area. The whole point there is that bin fills, you stop the conveyor for a few moments, you switch out that bin, put it back in. The whole time that press has never stopped, and you've improved your efficiency in your operations. In this particular case, they also had a part out that they wanted coming through the back of the press, and that's why you see this part out conveyor in the back. And then apply the same principle to a large press. So here we have the shaker. We're dropping down. When they did the installation for this 400-ton press, they expanded the foundation a little bit and created a space in the floor behind for an in-the-floor conveyor. We designed it so that the covers for the conveyor that you would drive on for setup or anything else actually open up and double as your scrap trays. And so the shaker is dropping. This catches anything that falls short or falls off, or if the tray is not quite long enough, and it shuttles it in the floor up and outside the guarded zone. Again, all the scrap is taking place and being removed while the press is operating in the name of automating that scrap removal process. Other things that you can do when you look at getting the parts out, or well, here I have a photo of another similar system here. In this case, they did not actually go below the floor. We're actually shaking into a conveyor that's condensing it down into one place, and then carrying up and dropping further back outside the guarded area. But this is that system, similar system in process. One of the other things that you could do is we talk about getting your parts out, right? We want to get parts out automatically. We want to stop reaching in. This is not necessarily groundbreaking in that using a conveyor to get the parts out. A lot of stampers are already doing that. The advantage here is this is automated to operate with the press. We've created a system where the conveyor can be moved in and out automatically. This is a simple automation to improve your setup time. We have a control down here that's got raise and lower for the conveyor start and stop. And then this also slides in and out. So you can manually slide it in and out to the distance that you need for the die that's set up. You can automate it. You can automatically raise and lower it. So you're not over there with blocks and making wrench adjustments and whatnot. You just flip a switch, you raise the conveyor, you get it in position, you slide it in. This conveyor is tied into the press control as well, so that when the press starts, the conveyor starts and it starts carrying your parts out automatically. Again, motion is monitored. If for some reason the conveyor stops, you'll get a message at the press to tell you the conveyor stopped and not working. Taking the next step from this particular conveyor is a more automated system. Now you see a more detailed control here, and I'll have the next slide has a little bit zoomed in image of this control. This is a much larger conveyor. This has got automated raise and lower. It's got automated in and out, and it actually has an automated tilt. So if you need to raise one end up in order to get over your bin on the outside, or lower the inside near to the die so that parts can fall off freely. But then with the control, you also can control the speed, and you could potentially automate all these functions utilizing a auto setup function. So some of you may already be using auto setup to set shut heights, set your counterbalance, set all those things. You could tie that in and use it, utilizing the recipe for the tool. Set your conveyor speed and locate in positions. We can help you do that as well. The next step up from that, this particular conveyor here, let me zoom in. This is through one of our industry partners, and this particular table is meant to handle a wide variety of parts or perhaps a multi-channel die. So I could carry parts out from different areas in the tool. I could carry scrap out if I want, or I could configure this to carry a much larger part out from automation. And basically the way this works is these outer conveyors move in and out, and you can see they have in the picture here, they have a long part on the top and it is spanning all 3 conveyors. They all operate together, but it is part of the recipe for the tool to set the width and the location of this to help get the parts out of the press. So this is another example of automating your conveyors.
Those are some awesome examples, Jim. Really fantastic. Who knew there were so many ways? I've got a stump the presenter question for you.
Okay.
What would you say is the most unusual or extreme challenge you've encountered, and how did you resolve it?
Okay. Well, I actually have a photo here for you, just for you. Let me share this again.
What a coincidence.
Yeah, it's shocking, huh? In this case, we have a similar setup, right? This will allow you to do the same thing. These conveyors will spread to manage large parts or channel or handle multi-channel. But what if I have a really oddly shaped part? And in the case of this, our industry partner was able to set this up to raise the center conveyor. The challenge from the customer was a large, I guess, triangular shaped part or U-shaped part coming out of the tool, and they didn't want that to fall. And so they developed this conveyor, again, all programmable, and this will support the top part of that U and carry the part out to the end where it gets handled by operators or automation to put on racking. So this was by far, according to our industry partner, this is quite a challenge to manage this part.
Very cool. Thank you.
You're welcome. Hope that answers your question.
It does.
The next thing I want to talk a little bit more about getting parts out of the press, and then I have a few videos and additional photos. This particular application, many operations are utilizing a knockout on a press. This is a servo parts catcher. So this is programmed to time with the press. The press knocks out and drops onto this. And then the parts catcher comes back and drops onto a conveyor. And these rings come out, as you can see, and they fall onto a post where they're managed for stacking. And then they can switch those out. They can pause the conveyor briefly to switch out the post for another part, or once it's filled. Taking the next step yet, this is for motor lamination press. In this case, you can see parts coming off the press very rapidly. And basically, this is counting the parts as they come off, managing a stack of them. And then once a full stack is done, and you'll see here on this, these fingers move in and catch the part and start the new stack while the stack below is taken away. So that you can get your specific stacks, your specific quantities needed, and the bottom stack will move away. It'll go out and it's set onto a chain conveyor and carried out to the stacking or to the next subsequent operations while the press is still running. Next thing we'll talk about here is bins. So a lot of times you'll have different bins. So this is another fairly simple automation, but this takes the step away of having to stop the press to change bins. Our customer presented us with a system that they wanted to be able to count parts accurately into bins and not have to be constantly stopping the press to change bins. So we worked with them to come up with this system. I guess I can't really make this any bigger, unfortunately. But you'll see here, parts are coming out of the press. There's still an operator there that's monitoring what's going on, but parts are being counted by sensors here at the end of the conveyor. And once the bin is full, you'll see that it moves out and kicks a bin down the roller. And probably advance this just a little bit. So you see the bin moves, and then what happens is we have a cleated conveyor there, and the operator can come in and just add additional bins to the end there, and this will continue to count and move bins out and change them out. So going back to what Lou was saying about automated bin change on larger, automotive operations, you could take that and you can make that a smaller scale operation for your simpler and your smaller parts, down to little brackets and simple things like that. Another project we did, same thing. There was actually 4 different parts coming out of a press, and these parts were coming out of 4 channels in the tool. We carried these out and we were dropping them into 4 separate boxes. Again, there's sensors counting the parts as they fall. So as the sensors count the parts and things move along, as the boxes get filled to their correct quantity, they'll pause the conveyor long enough to accumulate a few parts, and then it'll move the boxes down this. It'll spit these 4 boxes out down this roller conveyor and bring 4 new boxes into place to continue filling. Taking the next step up from that, of course, the systems that Lou was talking about. This is a large pallet system that goes on the end of a large automation. So there's a robot back here. Unfortunately, I don't have anything of this running. There's a robot, though, back here that is grabbing parts out of the press, carrying them over here and stacking them on pallets. And basically, you could put new pallets or racks on here. They'll move over to this area, roll in with a chain conveyor, and move back over to, so you have some accumulation going on here. And then the finished pallets come out here where they're retrieved by a forklift operator and carried away to the subsequent operations or storage. Another option to that, and this is another a large scale version, you'll see here, these are actually turntables where you'll have bins or racks stacked, and they have operators that are actually stacking in this case. So the operators are utilizing that spread apart conveyor system that I showed you earlier. The parts come out of the conveyor, they roll down to this table that's right here or right here in the image. The operators are able to grab the parts as they come off the table, turn around and hang them on a rack. And as the racks fill, these turntables rotate. So a forklift operator can take a full rack and then bring an empty rack to the next position. So these are all simple. I mean, this is not a very simple one, but I've kind of shown you the breadth of things that can be done to help improve automation at the end of your line here for bin change or even rack change. Other things you can do, we talk about robotic sorting and automation. There's two conveyors coming down here. This is utilizing a vision camera here, and this robot is actually picking up 2 different parts. There's a small cup here and then a large cup that's coming down. You can't see this other conveyor. There's a large cup that's coming down there, and it is actually taking them and stacking them into these nested conveyors where they get moved down to subsequent operations for assembly. But this conveyor is set up with a nest, and this robot utilizing the vision is quickly picking the 2 different size caps, placing them into these nests and moving down for assembly. And then last here, let me just advance. This is a large automation setup. This is obviously a transfer line here, but I'll just advance this here to show at the end of the line, instead of having parts just falling out onto a conveyor for operators to manage, this particular customer setup, the parts are getting laid into a shuttle. And then there are further on here, just a little further on here in the video, you'll see there are actually 2 robots that are grabbing these parts and stacking them on pallets into different areas. So, you know, it's timed out that one pallet will get filled before the next, and there'll be an end-on light or something that'll identify to the operators that it's time to come and grab a rack. And and in the meantime, the robots will start stacking in another space, waiting for the operators to come and pull those racks and move them to a new place. So at this, I guess, these are all the different things that we've been involved with, either directly or through our industry partners, and things that you could do to consider, and hope I've given you some ideas for end-of-line options for removing scrap and parts from your systems. At this point, I guess I'll throw this back here to Lou, and stop sharing here, and I'll open up to any questions if there have been any. I've kind of had a stream going.
Yeah, thanks, Jim. We actually do have a question from somebody in the audience, specifically about the turntable racking that you showed.
Yeah.
The question is that a powered rotate, or is it manually rotated?
It is a powered rotate.
Okay. And then yeah, go ahead.
Yeah, so basically they could fill a rack, and then there'll be like a button stand there or whatever that they could hit, and then that'll rotate the rack out and light up a light to alert the forklift driver that it's time to pull a full rack and bring a new empty.
Excellent. Thanks. And I guess my own follow-up question would be, all of this, you showed so many great examples. How flexible are those systems? They're not specific to jobs, or are they? You know what I
Sure.
mean?
No, that's a great question. Now, so the system at the end is maybe a little more set up to be, well, I shouldn't say it's fixed, but in that case, there'll be fixed grippers, right? But one of the things that you want to consider is what is your level of flexibility, especially if you're a contract stamper, job shop. Now, my history prior to coming to TCR was contract stamping for 25 plus years in the industry, in engineering, and I've done some projects like this. And flexibility is something you have to be that absolutely must be considered. And that flexibility can, you know, some of the simple things where we talked about the conveyors, maybe that's not such a case, except for maybe the part where the conveyors were spreading automatically and adjustable to manage different size parts. That's one level of flexibility. With robotic part handling or anything like that, you have to consider, can I change grippers? How hard is it to change grippers? You know, is my automation flexible enough to reach in? In my career history, we had a situation where we bought automation that was considered to be fixed for a fixed process. Fast forward 2.5 years later, that job was moved out of the country, and we were left with automation hanging on the back of a press that we weren't able to use for a while. Several years later, we were looking at a new job, and we were able to get back with the company that provided the automation, and we were able to make some changes to it to allow us to be flexible with it. You know, I guess the previous engineers that put the product in said, well, this is going to run here forever, and so we can use fixed automation. Down the road, we figured, now we need to be flexible with this, and we converted it from it was a 2-press solution where we were transferring a part from a draw press into a 3-station trim. Later on, we came back, and in that 3-station trim press, which happened to be a 1,000-ton mechanical press, we put a coil feeder on it, and we were feeding a coil 81 inches into that press, stamping a riding lawnmower frame, and using the old automation to reach in and grab that part and pull it out and stack them on a rack. And in that case, we were using our press controls to monitor. Each time a part got stacked, we told the lift table to drop a little bit, and once there were 30 parts on a rack, it would stop the press, and it would be time to change out that rack. But prior to that, that operation would require 2 operators, or possibly even 3, to grab that heavy part out of the press, place it on a rack, and then maybe another operator that's in the area managing racks. So flexibility is key. In the subsequent process that we did, actually, we did a metal forming article on it several years later. We were running in a 1,700 ton press, a 3-die operation to trim and pierce a lawnmower deck. But in that same press, we were bringing that lawnmower frame that was getting stamped in the 1,000-ton press. We were bringing that over, and then that was just 2 hits on a much larger part. And we had to have the flexibility to be able to change from the 3-station die, managing lawnmower decks, to a big long frame. So, and that is working with your automation partner to develop the right grippers. And again, scrap handling is key. How do you manage scrap? We were presented with a challenge on the 3-station die where there was one large piece of scrap that we could not split it up. There was no room to add splitters. We couldn't drop into our shakers. And we actually ended up using the automation to pick up the piece of scrap and send it out on the finished part conveyor along with the part. So yeah, flexibility is very key, and you have to really look at, especially as a contract manufacturer, what are the different options? What is the product mix you're going to see across this over time? And that all has to be considered once you get into your ROI.
Well, thanks so much, Jim. So many great examples, and we appreciate too your commenting on the importance of flexibility. I would like to bring Dean into this conversation, but first I just want to put out a reminder. Use the Q&A panel on your Zoom screen. Any questions pop up while we're talking here, please put those in and we'll get them addressed as we go along. So now I would like to bring along Dean Phillips, PMA's Director of Technical Training. And Dean, added equipment and technologies, they have to play nice along with the entire press line in order to achieve wanted gains. Can you speak to that and the importance of every link in the chain doing its job, not slow down other stamping line operations or hinder pre and post stamping processes?
Yeah, that's a great question. And it's something that when we look at the total package, when you're looking at what you're doing, as Jim had mentioned earlier, pre-planning and looking to the future and having an idea towards the evolution of a project is really critical. And it's also important to understand you involve all the parties that you're going to have. So let's take it, for example, when you're running through your tooling, my end of line automation may be limited because of a die design problem or a die design flaw. Well, that may be because you didn't include the die designer at the same time as when you were buying your press or you were buying your automation. Those things become critical later on. And you think about what it takes to get a part out. The original way that people did it was gravity. You tilted a press back on you leaned it back and you let gravity take the part out. That was one of the earliest ways that we did things. Then we started doing things with shakers and things like that still had to have some downward angle. Conveyors don't have that limitation because they are powered and they're turning and they're actually being able to bring a part up, out, and over. Same as with some of the magnetic ones too. You could take it at different angles. And now as you've gone to automation into things like transfers, the best way to do it is as linear of a direction as you can go. Everything that I do away from that limits how fast I can run. If I have to go up over guide pins and bushings, if I have to go up over, or if I have to move out around something when I'm moving the fingers or the arms around different objects within the tool, that becomes critical. So when you look at the line and all those forms, so there's mechanical issues of it being transferred. So there's mechanical hindrances that you see that slow down your production. I see people all the time say they want to run their press faster because they want to get more parts per minute out. That isn't always the solution. How you get that part out of the die can be the critical element. many of the companies that I go into in the last 30 plus years that I've been out there doing this, many of the companies, the limitation is not how fast the press runs. It's what you're doing with the time when it's not running. For instance, you see people use automated, well, all automotive manufacturers use some type of a line. And when they're doing those things, what they're trying to do is either make the parts run faster or optimizing the time when they're moving it from one place to another. The beginnings of this was doing a secondary operation as it's moving along. So as this vehicle's moving, can I do those other elements as it's moving along? Things like welding and other added value things. So as we've moved into getting the parts out, as Jim had mentioned, you know, how you handle a part can be part of the issue. You know, if the part falls and is damaged, that's not any good. Now you got a higher scrap rate. If the part falls onto the floor or somebody has to take the part out, flip it over, and they have to then rack mount it, or you use 2 or 3 people in order to do that, the problem becomes that you're not optimizing your process. So using the different elements, going to a conveyor or going up to a transfer system or moving into a robot, the flexibility that a robot gives you is one of the things that could really transform how you're running your end of line. If I want to take that part out and flip it over, or I have parts, I'm doing a 2 or 3 or 4 out die, how I'm managing those parts as they come out becomes critical to your optimization of the productivity. If you look at what is the cost that you have to hit, you know, it becomes difficult to look at that kind of thing. Justification that you use for doing this, number one, of course, is how do I do the process to the maximum ability? The secondary part of that is safety. If the part is ergonomically not very good for me, if I have to turn a lot, or if I have to lift higher weights and I'm lifting, turning, bending down, how I'm managing that part, that could become a critical issue for why you don't want to use people to handle certain things. Parts can be sharp. People can get cut. There can be injuries. Many press brakes have this issue because people are flipping the part, they're turning the part over, all those kinds of things, and they get cuts. And that could be lost time injuries. Same is true on presses, where if somebody's taking a large part out of a press, it can really be a huge hindrance to you if you're limiting what that can do. So if you start to look at the broader picture of where this comes in, there's more and more opportunities, I think, for most people to look at this. But you have to look at the scalability. As Jim had said, what happens when the press goes away or that job goes away? Those things become, what flexibility do I have? With today, with robots being easier to program, being able to have more range of motion, and people working alongside these, that really takes us to a new level. And it really makes us more productive and makes us able to produce more parts per minute at the end of the day, which is your justification. Once I can show that value that I've added through that process, that takes me to the next level.
Thanks so much, Dean. Now, with so much this discussion on optimization, if you could put yourself in a, metal former fabricator's head, what strategies can they use to incorporate this or to optimize their automation, both mechanically and electronically?
I would say that let me start from looking at it. The other problem is most of the failures on a lot of these projects come from not integrating properly. And I have nothing but the highest respect for TCR and Jim and everybody over there. Every integrator isn't at that level. I can tell you right now, many of the integrators fall far short of this. They leave it open-ended and they're like, well, there's an input, there's an output. You guys have to deal with that. We're not going to be responsible. We're not going to tie that in. Consequently, Many die crashes happen because it wasn't integrated properly. The position of the press isn't integrated properly. So when you're looking at this project, having integration factored in to what you're going to do is important. Safety, okay? Historically, we've seen many injuries. Now it's gotten better, but we've seen lots of people getting crushed by robots in past times because it wasn't interlocked correctly. If you can let people be around at a full speed and full torque running robot, that's a hazard. So you have to have, when somebody's in that area, that it has to run either on a pendant or it has to run at lower speed, lower torque. There's provisions that the robots industry has put in place to help limit that. But integrating it with the machinery has to be something that you look at the beginning side of things. What is the signal I need to tell that integration with an automation device, whether it's a transfer, whatever? I have to know when it clears the part. So on the way up, I have to clear the part in order for it to transfer. If I don't clear the part, what's going to happen? It's going to crash. Or if I come up and I only have enough time to get it from this point to this point, and it's on its way back down again, and I don't clear that area, that's also a problem. So the speeds have to be integrated. And if you speed up the machine, say, hey, I want to try and run faster. Okay. Can you run faster without compromising that speed and the velocity of the slide it's going to take when you actually come down? And could conventionally have a collision. So that becomes part of what you have to look at also. And that's where I say it is critical to have a good integrator that knows what they're doing electrically and mechanically to make this work smoothly. Now, I know many people, I used to see it all the times in my days back at Clearing Niagara Bliss, and even at Shea when I was there, all of those companies where people would say, well, I'm going to buy this part from you and I'm going to buy this part from them. Okay, what marries those two things together? If it's you, then you better know what you're doing to integrate it safely and follow in accordance with all the protocols that you have to address. But if you're going to undertake that yourself, be aware of the hazards that you have to watch out for from a safety standpoint, from a collision standpoint, from a downtime standpoint. If you don't address those, make sure you have a good integrator to help you with that.
I would add to that, Dean, it's incredibly important to understand, when you're talking about robots too, it's incredibly important to understand your programming. One of the key things I learned in programming automation is create that program point that tells me when my grippers are out of the press, completely out. The press will only fire when it's over here, but it won't fire when it's over here. And that point can change too with different grippers, right? So I put a little bit longer gripper on, and now I got to move that point. And it's very important to understand your programming. You talk about going faster. I mean, if you're using magnetics or suction or anything to move parts, suction there's nothing wrong with using suction cups, but suction cups and oily parts can't mix when you go fast sometimes. You can make them work better together if you have things on the gripper that will contain the part from sliding. But if that part is sliding because you're moving too fast, it will, like you say, it'll just go flying right out. So yeah, understanding your programming and the capabilities of the automation is huge.
Yeah. And as part of that, is the control that you're using, is it velocity adjusted? If it knows that I was firing a die protection to make sure that it would check to make sure it's in position by the time you get to 110 degrees, well, yeah, maybe I need to back that up some because of the inertia that I'm going to have. But because I'm running faster, I have to be able to allocate for that. And along with that too, there has to be sensors integrated into it to know when the part isn't there. It
Yeah.
fell off. You need to know that before you stroke the machine again and now damage you have one problem where you drop the part. You have another problem when you come down and crash against it now. And that could be even more detrimental because now you're down a day or more to repair a die.
All incredibly important considerations.
Thanks, guys. So I do have a question, and we're definitely going to open it up to our audience as well. If you want to use the Q&A panel and ask these guys some questions while we have them available to you, take advantage of this opportunity. But for end of line stuff, especially conveyors and picking, sorting, how easy is it to reprogram that equipment when you change press speeds for whatever reason? Obviously, if it's an operator and the press runs a little faster or slower, he's going to be able to adapt. But I wonder if the press operator or a plant manager decides to run faster or slower, does the automation automatically follow, or you got to go in and reprogram the automation? And how complicated is that process?
I'll start with that, I guess, and then Jim can chime in too. It's in many of today's controls, it is not that difficult. Many of them have a slide velocity built into it to know and adjust their cams, programmable cams, to tell when those angles are going to happen, and also on the sensors to know when things are happening, and also be able to give you feedback of whether or not the sensors are opening and closing like they should. Those kinds of things are certainly critical to making sure that the process runs smoothly. Jim, you have anything to add to that?
No, I would say that's probably right. A lot of the more advanced controls that are out there, and especially if you're looking at like a servo press, right? So a servo press, you could be running in full revolution, and now you want to speed things up and operate in pendulum. Generally speaking, very generally speaking, the press control will handle most of that for you. But in the case of some of those, you may have to make some adjustments, but they should be fairly simple. It all depends how deep you want to get, right? You may have to speed things up a little, but in some cases, the press will tell you what you need to do.
Yeah, and to add to that, I think Jim makes a very good point there, especially on servos, because when you start running in pendulum motion, you're trying to optimize that stroke. And if you're doing it for the purpose of like a blanking operation where you just want to clear where your part just clears it, the time that you used to have was all this time. So as you're making a stroke, you were making this full length stroke, and the time to transfer or move a part from place to place occurred during the non-productive part of the stroke. The reality is when you go to pendulum mode, you lose a lot of that time. And by moving it down a little bit more and trying to get more conservative, you may have more issues with your transfer mechanism or your robot getting in and out of those locations too.
Yeah. Thank you. I want to follow up a little bit on Jim talked from his previous days working for the contract stamper about the return on investment calculations. And it's easier to do, I think, a return on investment when the system is running and you've got some hard numbers. But what kind of advice can either of you give to, let's say, a production manager who's trying to cost justify this to his upper management before they've made the investment and they don't have hard data that they can go back and look at, but they want to predict what the outcome of an investment in end-of-line automation would be. Based on your experiences, both of you, what's the best way for somebody to go about doing those calculations and figuring out what the return on investment will look like when they want to present this to upper management?
Well, ultimately, ultimately the management's going to set a time that they expect a payback, right? And you have to figure out where that payback is going to fall, and that, and again, the things that you're looking at ultimately is safety, quality, and productivity, right? So safety can be a little hard to quantify. Unless you're keeping really, really good data. Now, no, we don't want anybody to get hurt. And if somebody gets hurt, that can cost a lot. But, if your company is collecting any of that data on downtime, you're looking at an operation where they're reaching and they're lifting a heavy part out of the press, and you have back injuries that occur all the time because they're reaching and lifting heavy parts. Or sharp, we're getting a lot of cuts and I have to send guys for stitches and now I've lost time or they're on light duty or something like that. I mean, those are things that can be quantified, but not all companies will quantify them specifically, but it's something to consider. And then part quality, like Dean said, am I dropping parts? Are things getting dinged up while we're moving through the process or dropped into a container? Do I have an operator at the end because I don't want parts to fall? They need to be stacked neatly. There's a quality cost. There's a cost of quality that comes from that. And hopefully you're collecting, presumably in this day and age, you're collecting that kind of cost of quality data. Other than that, the big thing is to go out and do a time study on the process. If with the lack of those things, you want to go out and do a time study of what am I doing currently, and then work with your automation partner. Most of them, our industry partners particularly, will work with us, and we'll come to them and say, well, right now we're using 5 operators, and it takes this many, it takes this many minutes to create a part, and I'd like to get to here ultimately. Can we do it? And then your automation partner will work with you, and they'll tell you what they think they're capable of doing. The instance that we talked about earlier in, I guess, in my history, we had 5 operators on a press with 3 stations moving a lawnmower deck. The lawnmower deck was big and oxy to move. At the end of my automation project, it was down to 2, and loading the press was done. They were picking up a part with, they were loading it, the automation manually. They're putting a part on a shuttle and it would get carried into the zone, but he was doing it with a lifting mechanism, right? So his job went from leaning and reaching and lifting a heavy part with big sharp flanges to lifting it with a vacuum system and setting it on a shuttle. At the end of the line, instead of grabbing it out of the press and walking over here with carrying a 30-pound deck and setting it on a rack, it was coming out on a conveyor at an appropriate height that was ergonomic for the operator to lift. He was able to easily take it off the conveyor and set it right on a rack. And we saw fantastic productivity gain. We saw about a 50% increase in productivity and a reduction of 5 to 2 people, and that was very easy to quantify in that case. What that cost was. We went from 50 parts, less 50-ish parts per hour or whatever to like 75. It was an incredible increase. And then with the reduction in people, it was a fantastic gain. But yeah, so it's looking at those things, looking at those. What are your current costs? What are you currently doing? And you may have to do a time study to understand what you're doing now, and then do the math to be able to present it to your management team.
Yeah, I'd like to add on to that. The number one thing is starting now and having some numbers to benchmark where you are today. Most continuous improvement systems, one of the limitations is that you're trying to improve what you do now, and it's not always forward looking to what I want to do in the future. I can get really efficient at hammering nails, but then when a pneumatic nailer comes down, it's a game changer. But you have to understand that there's an evolution to things. Just like in the past on different types of presses, you had a standard motion press, and then you had a link motion press, which many people misdescribe it as slowing down at the bottom of the stroke. I don't describe it that way. It accelerates through the non-productive part of the stroke. That's what a link motion press does. And it slows down at the bottom in relative speed to the rest of the stroke, but you're able to produce more parts per minute. That's the value. Same with servo presses. The value is that you're going to optimize your stroke length. Same is true with automation. I want to optimize that time. Anybody who's been in press maintenance can tell you one of the worst things is stopping the press. If you're running in single stroke or you're running in automatics or continuous on demand, which in continuous on demand, you're going to build so many parts until the conveyor or the chute or whatever area you're holding parts in. Once that backs up, then you stop running in automatic. Then once that shuttle clears, then it starts making parts again. In both of those cases, when you're slowing down or stopping, or you have to run in single stroke because your people can't handle the parts when they're running it, then you're probably running too fast for what you're doing, or your bottleneck is that automation. If that automation is currently 2 people, then yeah, then that's going to be an issue. So you have to find ways to optimize that through automation, because whether you like it or not, the workforce shortage is here, and we have to deal with that. That is a real problem, and most people can't even staff 3 shifts like they used to. They may be barely struggling to fill 1 shift, and that becomes a real big problem for us moving forward. So automation does pay for itself when you start adding in all of those other factors.
Yeah, sure. If you can't find enough people to staff the press, the automation is automatically it's gonna be
Yep.
easier to pay for itself just by turning the press on, right?
Yep.
Couple questions from our attendees, and we've still got some time, so go ahead and use that Q&A panel. Maybe in a little bit different direction, but you guys are both qualified to answer this. What are the key elements to consider to improve the die setup time for progressive operations? How can we speed up our die setup time?
I'll start on that. One of the things that you have to do to optimize your die setup time is having a plan. Okay, whether that is so that the material, that all your tools are at the same heights when you're loading your tools. So is the pass line height standard or pretty close, so that you don't have to do any mechanical lifting of the feed line or anything like that. That's one of the first things you do. The other thing is, how do I get the part, the tool in and out of the machine? How am I doing that currently? If you look at it as whether you have lifters and automatic clamping systems, that always improves it. I've used the example, and I hate to use a brand name, but I will anyways. You know, Toyota got down to their 5-minute changeover for their line up in Kentucky, and one of the things is that it's all the elements. It's that the rolling bolsters roll out with the tool. The new tool rolls in. That's how you optimize things, is speeding up that process. So you have to know the time that you have now, and where are the factors that are causing the problem. Is it clamping? Is it somebody going over there? Is it that you can't find the tools? That's always a big complaint that I hear, is we don't have the tools, or we don't have adequate tools for it. So all of those things all impact it for your die exchange.
I'll jump on that a little bit too, because that's a problem that we work on a lot at TCR. And some of the conveyors that I was showing are basically set to go on the end of progressive die systems, and our whole a big, I guess, ethos of ours is trying to help you get faster and improve your setup times. Now, again, as Dean said, having a plan, understanding, having die standards when you're building your dies, that this is always going to be my pass line height. If you can standardize it, great. If you can have it within a short window, even better. Putting your dies on plates with die locators. So if you don't have rolling bolster, putting die exchange plates with locators on the bolster. A typical, if I walk into a typical TCR installation, we work with our channel partners, and we have we use magnetic die. We'll try to use magnetic die clamping if that's something that the customer is interested in. That's 15 seconds to clamp a die. You press a button, you turn a switch, 15 seconds later, the die is clamped. We'll put rollers in the bolster. So, you pull up, you lift the die up, it rolls out easily onto the forklift, you take it away. Hopefully, you know where the other die is, or it's pre-staged nearby. You bring that die, you set it in, you roll it in, push it in position. drop the rollers, bring down the ram, flip the switch, and it's connected. And having the die on plates like that is the key to making sure it's in the same place front to back. It's in the same place left to right. You know where I need to bring my conveyor in on the end. You know where you're starting, you know, and then utilizing your press controls to the best of their advantage to set shut heights, to control the feed length programming for your, you know, a lot of press controls, you can tie that right in. It'll control you call up that die, the press moves to where it needs to be, it sends a feed length information to the feeder, and all you need to do is advance up to that first stop. You advance the part through the die until you're ready to go, and turn it on and go. And getting to, you know, less than 10 minutes is you know, it sounds like a big task, but there's some very simple things that you can do to get there.
Thanks, guys. Yeah, I mean, you know, Kate and Lou and myself, we've all been in a lot of stamping plants as you guys have, and we've done a lot of articles in the magazine on quick die change. And yeah, there's a lot of equipment, a lot of technology that's become available to make it quicker, to do clamping and stuff like that. But we also see that it's the process, right? And the plants that do it, die changes the best are the ones that have a process in place. They have, you know, one or two people who's responsible for making that die change happen, and they know what they have to do, when they have to do it. They've got tools, as you said, Dean, readily available to them. And as soon as that, you know, it's time to change jobs, they know what they're doing, and they make it their responsibility to get that die changed in whatever the standard is, 5-10 minutes, whatever it is. But
Yeah,
it's not an after the fact, you know, oh, we got to go change that die. It's like they know that they've got to do this, and they've got so many minutes to get it done.
That is working with your engineering department, working with your tool room, and working with your tool and die makers if they're external. You know, help, you know, have them help you create your standard, but know what your machinery is and what it's capable of, and you know, and then, you know, find yourself a good industry partner to help you get to get where you're going.
And you think about it, all you have to do is look at a pit crew in any car race. They all know where they have to be. They all are doing something that's very important to each element, you know, changing the tires or filling the gas, whatever that role is, everything is optimized to make that as efficient as possible. If you think about that in terms and you try and expand that into the stamping world, you can really make a lot of progress just by understanding what are the limitations that you have and optimizing those, but also certainly be open to new technologies. Look at the new technologies that are available. Look at the new clamping systems. Look at the magnetic style. There's more things that you can do, but you have to benchmark where you are today. Because, you know, somebody said in weight loss, they said, you know, it's where you start is where you are. That's it. You know, you can make excuses and say wherever you are is whatever, for whatever reason. It doesn't matter. Today is where you start. Okay. Doesn't matter about yesterday. Nothing matters. The only thing that matters is where you are today. And you can only move forward from here. You can't look backwards. You can only look at where you are today and move forward. So start by getting those metrics.
Yeah, the race car pit crew is a great analogy. Jim, this one might be a little challenging for you to answer, but I'm going to ask you anyway from our audience attendee. Can you give some rough idea of project costs for some of the examples that you showed, maybe for the last few that you showed, just a rough project cost idea, or would you rather not talk about?
Yeah, I can't specifically say on some of these because I wasn't directly involved in many of them. You know, I'm looking at, I saw the question pop up and I scrolled through the last 4 or 5 things there. And I mean, you're definitely in the, you know, several hundreds of thousands of dollars for some of those automated, for those highly automated systems with robots like that. And even particularly for like the rotating, rack change out and stuff like that. You're easily in several hundreds of thousands of dollars, if not more, you know. So that that's about the window I could give you. You know, it's very dependent upon what your specific situation is.
Fair enough.
Thank you. Do have another question from an attendee. With so many choices in automation, from suction cups, grippers, magnets, basic conveyors, etc., what are some things to consider when evaluating what's best based on an operation? Can you give some examples where how you can choose between maybe gripping systems or conveyors depending on the application?
Sure. So most of the projects I've done have been with suction. But it really definitely depends on your specific application and what the tools are and how quickly you need to move. You know, if you're talking about a transfer, finger tools are definitely great. May not be perfect for everything, but you know, finger tools are going to be the fastest, right? Because you're coming in, you're picking up at the edges, and you're moving through. So, you know, the answer to the question is very application specific. Suction or magnetic, there's pluses and minuses to both, right? Magnetic is great. Potentially, you could have an issue with cosmetic things for magnetic. Suction maybe a little bit better for cosmetic, but if you have oily parts, you could have issues there. There are ways to overcome that. You know, when we created a gripper that was going to be moving a heavy part that had a lot of oil on it, we would put like UHMW pads on the outside of the grippers that would come down around the outside, so it would prevent the part from sliding while it was moving. You know, but I've seen big heavy parts with some level of oiliness to them being carried by suction at very high speeds for that matter as well. So it is kind of application specific in my experience. I don't know, Dean, if you've have any other.
Yeah, no, you hit it on the head. It really is application based. What is the weight of the part? What is the speed you're trying to move at? Those are all factors you have to look at to try and figure out what's the best direction to go. And today, one thing that's really incredible with robots and end effectors that you can attach, whatever the configuration of the part is, especially with 3D printing, people can 3D print their own end effectors to customize, to fit in where tabs are or holes are, or whatever the shape of the part is. There's more ways today to come up with that. Used to be you were pretty limited, but today most companies that either do transfers or do robots have a broad catalog, and customizing is really easy nowadays, so that you can go from one part to another much quicker and have much greater success than you used to, even to where you have like these on end effectors for robots where it's a tentacle style, where it wraps around and lifts parts that might be very open to being damaged or having some other issues with it. There's so many new opportunities out there. I really encourage everybody to explore all the possibilities, because there's probably something out there. Somebody's probably done the same thing in the past. So consider that.
And along those lines, can you comment on a particular application, say handling sharp edge parts? Do you have specific recommendations for that?
When it comes to sharp edged parts, that's one of the advantages of going to an end of line automation system, so that you don't have an operator or somebody there handling those sharp edges. Obviously, we'd like to optimize where we don't have those sharp edges to begin with, but that's just part of it. You know, when you're making parts, there are going to be some sharp edges in there, and especially on thinner gauges materials. And frankly, we even stamp things that are sharp, like razors. So some of those things have to be handled in a little different way. The trick is where you grip the part, because that also can be part of the problem. Is anything that has a sharp edge can impact and cut into things like suction cups, or into even if you're using the tentacle style or something like that, that has elements that wrap around a device. All of those will get damaged over time of running against rough or sharp edges. So that's where some of those magnetics sometimes have an advantage, is going in that direction. Jim, did you?
So I've got I've got to stump the presenters question, another one. So thinking of these scenarios we just talked about, let's say you have an aluminum part. You can't use a magnetic gripper. It's oily and it's sharp. What are your recommendations?
I would say, so the first thing I would say is that people think sometimes magnetic has to mean that it picks everything up magnetically. Sometimes a magnet can turn on and off an actuator mechanism, so it magnetically closes an arm or something. Whenever we've had in applications in press brakes and in shears and other things like that, where you had a material that's non-magnetic, there are other things like using other actuators to grip or hold something in a little different means. But if it has a sharp edge, then you have to have something that has some give to it that isn't going to get damaged on a regular basis, like cups or things like that. And if it's oily, it's oily. That's, you can do things to, as Jim had mentioned earlier, there are ways to work around oily materials. It's just a case of getting some level of friction and getting some level of weight management too, so that when that part's moving, it isn't just shifting off of that mechanism. Jim, what else have you seen out there?
Yeah, I would say again, Kate, probably going to be a little bit application specific, right? So, you could get away with finger tooling. Chances are, if you're using finger tooling, you have to be able to come in from both sides. Potentially, you could reach under like a fork and lift the part and carry it over, or you could create kind of a nest that'll come in and pick up around the sides, presuming that the die is configured to release that part to a state that you can get under it, right? And then your next station will locate appropriately. You can consider something, looking at aluminum, you could go with suction. You could just go with a lot of small cups to try and avoid the areas that are sharp. So there's plenty of options out there. I would say it sounds like it's likely a finger tooling issue. So you're not touching burrs, you're not grabbing. If it's a really oddly configured part, maybe that's the case. Yeah, it's definitely going to be an application specific type of thing.
Yeah. And feel free to, if you've got questions like this, feel free to reach out to us. That's what we're here for. That's why this association exists, is to try and find solutions for you. So feel free to reach out to us, or email us, or email Brad or Lou or any of the staff at PMA, and we can certainly help you find a solution.
Exactly right. Yep, that's definitely what we're here for. So thanks for that, Dean. All right, well, that's a wrap on another very enlightening episode of MetalForming Live. Thanks, everybody, for joining us today. Thank you, Lou, for moderating, and Kate for participating as well. And of course, a huge thanks to our panelists, Dean and Jim, and again to our sponsors, Stamtec, CE Presses, Nidec Press and Automation, and Principal Financial. Please be sure to join us for the next 2 MetalForming Live events. July 24th, we'll discuss how new higher strength materials are impacting best practices in the press room. And then on August 6th, we'll talk about best practices related to press brake bending and tooling selection. So we'll see everybody then. Again, thanks for joining us today.
Thank you.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you